Okay, geometry, go ahead and look on page 614 for me, please. There's a couple of paragraphs at the top. I'd like you to go ahead and read those. Look at the picture to the right, and then read theorem 11.7. Okay, read theorem 11.7. Go ahead, stop the video, and read that for me. Okay, so you guys are back now, and this theorem is pretty easy, but the first thing I want to make sure that we're talking about is we know that there's a difference between this angle and the angle we learned earlier. All right, so there's a word called an angle called a central angle. Okay, hopefully you remember what that means. And a central angle, right? If I have a circle, okay, a central angle means the vertex is the center of the circle. That's why it's called central. And the rule with the central angle is if this angle is, let's say, 80 degrees, this arc measure is 80 degrees, right? That's what central angles do. These are different, okay? This is an inscribed angle. Inscribed meaning it's inside the circle, right? See how this vertex is touching this circle? See how this vertex down here is touching this circle? All right, it's different than this, okay? So this rule is an old rule. It's going to be a little different today, so you have to know what type of angle you're dealing with. Now, the good news is this. Theorem 11.7 that you just read says that the arc, okay, the intercepted arc here, this blue arc, is twice as big as the angle of the inscribed angle that it came from. All right, so that's pretty easy. Now, the converse of that, right, if we do it reverse, that means the inscribed angle is half as big as the outside arc. Okay, and remember, arcs are measured in degrees. The other day we worked on arc length, right? Arc length is measured in like inches, centimeters. That's like the distance. I'm not asking the distance of this. I'm saying how many degrees this has, and it's 100. So pretty easy. It's asking, this is example 1 on 614. This is problem A. It's asking, how much is this angle? Okay, so if the arc is 100, this is half of that. Okay, the angle is always smaller than the arc. Okay, so what's half of 100? You could say 100 divided by 2. It'll tell you that this this angle here is 50 degrees, right? Half of 100. All right, so now the opposite of that is, see, before they gave us the arc and we were supposed to find the angle, here they've given us the angle, we have to find the arc. Now, if you're wondering why that this W is up here, it's because this arc is larger than 180 degrees, right? This is a major arc, so it needs 3 points, right? We call it ZWX, or we could call it XWZ. This was a minor arc, so we just call it, right, we use 2 letters. We say like NP or PN, right? Minor arcs have 2 letters. Major arcs either have 3. So we could say ZWP or XWP. So that's why that W is there, to tell you that it's a major arc, all right? Now, let's get to the problem. If the angle is 105, remember, the arc is double that. So we'll take 105 and we'll times it by 2. Right? Remember, it's the opposite of this problem. This time they gave us the arc over here, so we said 100 divided by 2. We want to find the arc, we times it by 2. 105 times 2 should be 210 degrees. Right? ZWX is 210 degrees. Okay. If you have any questions, let me know. Relatively short today, but I know it's a little confusing. Remember, we started talking about the central angles. Central angles are different. Central angles are exactly the same. This one, the arc is twice as big as the angle, and the angle is half as big. The angle is half as big as the arc. I do have some problems I'd like you to try, you guys. So go ahead and go to page 617, and I want you to do numbers 3 and 5 for me. Okay? If you have questions, let me know. Otherwise, good luck.